Hey guys, we're Group 17 and today we'll be presenting on the topic towards personalized learning and mobile sensing systems. So when we talk about Internet of Things and personal devices in general, our aim is to always go for a better user experience. Let's say that I really like ice cream and you are lactose intolerant. If we both get a push notification from an ice cream company, then it's really relevant for me, but it's not so good for you. So the thing is that trying to make things personalized while maintaining good security standards is hard to achieve. But machine learning algorithms can help provide this if we use a system of a local model and a global classifier. So the idea is that we have a local classifier on a handheld phone, which will be trained on the user's personal data, and we have a global classifier that will take into account all the users' data and try to model commonness between all the users. So something like a global classifier can also be used as a reference in all the local classifiers because you don't want to retrain the local classifier every time. So you can have a global classifier, and based on the already pre-trained classifier, you can basically retrain some parts of it rather than the entire model. So a system like this is kind of presented by PLOS, which is also known as personalized learning in mobile sensing systems. So what PLOS suggests is that we can use a combination of two models hosted at different places to potentially achieve better performance than a single classifier. And the idea is that we basically want to perform a binary classification task. And when we want to do that, we have instances where we have unlabeled data due to privacy concerns. The local machine tries to label all the data within two classes. When we have unlabeled data, then we have the optimization process which tries to approximate the unlabeled data to at least one of the classes. After it has done that, we try to find the best fitting hyperplane so that the classification accuracy of the algorithm is high.
Okay, thanks AK for introducing the general idea of PLOS algorithm, and I will introduce more details about this. So we know that PLOS algorithm has inherits the spirits of the SVM algorithm, but actually they have some great differences between these two algorithms. So for SVM, it cannot handle something like the data are not labeled, and also they cannot find out the uniqueness of different data sets. So we have to solve that. We have to identify the commonness of the user's data, and also we have to capture the individual characteristics of the data. So for that, we generate the idea of PLOS algorithm, and we have to maximize the margin of the global hyperplane, and also we're trying to minimize the differences between the global hyperplane and those of the users, so that we can find out the uniqueness of the different data sets. Like this image has shown that the PLOS algorithm first find out the hyperplanes like this red line. It actually is the commonness of different data sets. Actually, is the common data sets. And for different colors arrows, like the green one, orange one, and also purple one, actually these are the uniqueness of the data sets, which combine the biases of different data sets, and with the global data sets, they can get a personalized hyperplane. This is the concept of the centralized PLOS because they upload all of the data to the server and let the server do the calculation. But this may also cause some problems like privacy issue because someone may get the raw data of the user, and also because of the bandwidth or energy constraints, it may cause some latency, and because of the server will do all the computation at a single machine, it may cause a lot of time. So to solve this problem, we propose a new or better solution, which is called distributed PLOS. Actually, it applies the distributed series or distributed mode to the PLOS algorithm. And the basic idea is that it separates the task into different small tasks and lets the small tasks to do as the local machine. For every users, they do the calculation of their own data as their own machine, and they only have to update the parameters to the server and update the global model with their own personalized parameters and get their local model. And then in this way, they can greatly improve their effectiveness and also protect their privacies. And for this distributed algorithm, it has a lot of like real time application, like the advertising system and also personalized searching system. And this system, they can calculate their search history and their search data so that they can get their personalized advertising results. And that's all of my part. And let my partner Zheng will introduce more about the experiment data.
Okay, and how to introduce us why we need the PLS and what the PLS is. Now I will introduce how the researchers have done experiments and what the experiment result is. So the result has used three different data sets to test the performance. It's smartphone data set, wearable sensor data set, and synthesis data set. And the author also used three different baseline methods to compare the accuracy. The three different baseline methods are all single and group. So under all three different data sets, and under two scenarios of with and without labels, our proposed PLS always perform the highest compared to three different baseline methods. So we can come to the conclusion that our PLS, which is personalized learning framework for mobile sensing, perform very well in terms of accuracy. And in the distributed PLS version, the The experiments also show that it's very efficient in terms of energy, computation, and communication cost, and it also provides privacy because it do not need the user's data onto the server. Thank you, that's all.